periodic table is very useful for predicting uh, properties of atoms. And so, for example, metal atoms, atoms of metallic elements, have a tendency to become cations. So the type of element that tends to give you positive ions in nature are the ones that are the metallic elements. So let's look at some patterns that have been observed. Sometime later in the semester, we will learn why these are the we can try to understand why these are the patterns. But for now, let's just take these as known facts. Okay. So alkali metals, those belonging to group 1A, are always found in nature. If you find them as ions in nature, they always have a charge of +1. You can't find them without any other charge. Okay. Now you can force them to have other charges in the lab under adverse conditions, but in nature, if for example sodium right here, sodium is an example of an alkali metal. So if I say sodium ion, you should already immediately know that that sodium ion has a charge of +1. So if I ask you for the formula of sodium ion, you say Na+. Okay. The alkaline earth metals, group 2A, are always found in nature. If you see them as ions in nature, if they exist as ions in nature, they'll have a charge of +2. So for example, calcium. If I say calcium ion, then you know because it belongs to group 2A that it has a charge of +2. Aluminum ion in nature is always +3. You're not going to see aluminum +2 or aluminum +1. You're not going to see calcium +1. Okay? So these are patterns that you need to remember. Transition and post-transition metals, where are they in your periodic table? Now, this would be your transition, right? And your post-transitions would be these, right? They vary. So you may find them with +1, +2, +3, or +4. Some of them just +2 and +3. Some of them just +2, but it varies from +1 to +4. The most common charge you'll find is +2. So if you have to guess +2. Okay. Zinc, cadmium, and mercury, the monatomic ions that you get from zinc, cadmium, and mercury are always found to be +2. So that's a good thing to remember also. 2B, yeah. So 2A and 2B, you might say, the monatomic ions you can get from those would always be +2. Okay. So let's look at a few examples here based on that. Sodium, right here. Sodium ion? What would be the symbol? So Na+, because it's got a +1 charge. Potassium. Where's potassium? K. So what? +1. The next one is calcium. Gave that example earlier. Calcium, group 2A, +2. Barium. What would be the charge? Ba +2. Aluminum, always. It's in group 3A. That's another way to remember it. It's always +3. If it's an ion. Zinc, +2. Okay? All right. Now, how do you name the monatomic cations? The main group cations, the names of those cations is the same as the name of the element that it came from. So Na+, it came from sodium atom, it's called sodium ion, so it's sodium. Ca+2 came from calcium atom, so its name is calcium ion. Okay? Now, transition and post-transition elements, okay, the cations for those, because you can get more than one possible charge, you have to specify the charge in Roman numerals, okay, to name it. So for example, cobalt can be +2 or +3. So if I ask you to name CO with a 3+, this formula right here, you have to tell me this is cobalt, and then in parentheses, and then Roman numerals inside parentheses, you tell me what the charge is in Roman numerals. So this is cobalt 3 ion. Okay, and that's just because it's an ion that's known to exist in more than one with more than one possible charge. Okay. So which of the following would be called magnesium ion? Here's magnesium right here. A, B, C, or D. Group 2A. That's the charge. So which one is magnesium ion? Mg plus 2. Okay. Now A, B, and D are all ions of magnesium, but they're not the ones you would find in nature. Okay. So those can be made. They probably not last very long, but you can't find them in nature. The magnesium ions that you find in nature are the ones that have a plus 2 charge. Okay. So metal atoms have a tendency to become positive ions, cations. They have a tendency to acquire a positive charge. So what would be the formula of lead? Open parenthesis IV ion. What does IV mean? Roman numeral 4. So what is the symbol for lead? Pb, as in plumbing, lead pipes. Okay, Pb is lead, and the Roman numeral 4 means you put a 4 plus there. So that would be the formula or the symbol for lead 4 ion. I have to specify the charge because I can't expect you to know what the charge is going to be. Okay? If I say lead ion, you're going to have to ask me what charge. But if I tell you sodium ion, then you know the charge is plus 1.